Okay, we have a research institute asking a poll respondents asked how they acted to annoy a bad driver. And we've been given this information about the poll. And we've got 1,128 of 2,579 who honked. And we want to construct a 95% confidence interval. So first, what's the best point estimate? Well, we're doing with the honking. So we're going to do 1128 divided by 2579. And this, so let's see, round to 3 decimal places, 0.437. This is our estimate, 0.437. So all we're doing is based on ours, what's our, kind of center. And then we want to identify the margin of error. Okay, now remember what the proportion, and this is if you come look in the course shell under assignments, test resources, I have a formula sheet, but you could make your own. You can see right there the formula sheet. The formula sheet I have is this one. You can see right here with the proportion, this is what we're creating. We're creating this. There's our point estimate we just found, our 0.437. And the idea is there's a certain error it's going to go each way, and that's going to make our confidence interval. We need to figure out the error. We need to figure out this right here. So this is what they're asking for. So to do that, you can see here what I've done is I've simply put in the information. Now, let's write down P2. I didn't write that down yet because I hadn't figured it out yet. No, I don't want to learn more about that. Okay. So what did I say it was? Not there. I have too many screens. 0.437. So because in this way I don't have to come look it up later. Now I need to figure out E. So I know my P hat, which means I also know my Q hat. I know N. What I need to figure out is my Z score here. And now remember, we always want to draw the picture, and so I'm going to actually draw the picture here. So let's make a picture. Badly, but we'll pretend I can draw. Looks like something, right? We always, on a confidence interval, we're always two-tailed. You can see that alpha divided by 2, but it makes sense. You have two sides of confidence interval, you're going to be two-tailed. So I'm going to have something in each of these ends. I have this, and I have this. So what I have going here is I have these two areas. And I was told, coming back here, that I want a 95% confidence interval. That means I have 5% that I'm saying can be out here in my red area. I want to know the middle, what's most of my stuff, but out there I'm going to have that. Well, that means that there is 5% between both of these, which means there's 2.5% in each one of them. So each one of them has an area of 0.025, 2.5%. I need to know what the critical values are. What's this dividing line here? Well, that's where I'm going to use my chart. So when I look this up, I am looking up in the, I already have my pencil chart. In the body, I'm looking for this area, 0.025. So I'm going to start looking for that, 0.025. Let's see here. It's here somewhere. I always find this is the hardest, and let's see here. No, I'm getting close right there. 0.025. Nice and even. If it's not, obviously just the closest one. So I go back up here. There's a 6. Here's a 1.9. So coming back here, my critical value is 1.96. Notice I didn't put in the negative. Well, remember, this is symmetrical. So that means if I looked here, this is negative 1.96. Man, I don't want to write a 6, do I? And this over here, this critical value is 1.96. But when we put it in the formula, we always put in the positive one. Because what we're going to do is the negative and the positive are going to come in right here. It's already in the formula. So when you put it in here, you're always going to just put in the positive. So let's build this now. So I'm going to take this down here and let's build this. So I just found out what my Z is. And this is the biggest thing I see. Everyone gets all this up, but they don't have the Z-score right. So make sure you can find that Z-score. So this I just found is 0.437. This is 1 minus 0.437. It's everything else. And then down here, this N is my 2579. Now I need to know what this is. So Let's get out my calculator. So I'm going to start here and I'm going to do 0.437 times 1 minus 0.437. Okay, then I'm going to divide. I like to do them in segments, but you'll notice I never actually, honestly, I'm going to start this over again. What I would do if this was me, I probably wouldn't do this. I would probably have never taken this out. I would do this divided by 2578. And then I would do times. You notice the answer comes up, but if you down here second the negative sign will give you this too. 1 minus the answer. There we go. So that's the 0.437. This is 1 minus the 0.437. Then I'm going to divide by 2578. So here's the rules on rounding. If you can, don't round until the end. That's the best case scenario. If you're not good enough with your calculator that you have to round, always round to more than 1 dp than you want in your final answer. Okay, so now I'm dividing by this. Then I'm going to take the square root of it. Notice I've never rounded anything. Then I'm going to times by 0.196. And there's my answer. So this right here, I was going to write this down at 0.019146. I don't need that many decimal places. This is my answer. So when I come back over here, 0.01915, something like that. We'll see. I don't think I need that many decimal places. So that's my error. So I'm going to come back here and I'm going to put this in my working one here. So this rounds to 4 decimal places. Okay. 0.0191. Okay. So far I'm doing. Now you'll notice this is a really long involved formula. Getting familiar with your calculator is important. You obviously do not want to be doing this by hand. Knowing where all the buttons are, being able to use the answer key, that's all very important. And I have an entire video just talking about the calculator. Now we want the confidence interval. So that's then, looking at this, I'm going to go back. I'm going to use my point estimate. So that's this 0.3437. And I'm going to add and subtract this value here. So taking this down here, what I have now is I have my point estimate, which we figured out, right? That was the 0.437, and I'm going to subtract the error, so that's my 0.191, and then over here the same thing, 0.437, but now I'm adding this. So what I'm doing is on each side of it, I'm subtracting and adding this error, and that's going to give me my confidence interval. So when I come in here, so I'm going to do 0.437 minus this, and then I'm going to do 0.437 plus 0.09. This is where you will have to round. I'm pretty good with my calculator, and I always end up at this point doing some rounding, but I'm pretty close, so I'm feeling pretty good about that. So now my answers are 0.41785 and 0.4561. So let's go back and see how many decimal places they want. 3. So as I said, you always round to one more, so you would never round, you would always keep 4 until you get to the end. So I'm going to put in, so 0.4179. Oh, no. I just said 3 and I was talking. That's an 8 then. Oh, now it doesn't want to put in. Okay. And then I have 0.456. Let's check the answer. Okay, so we're doing pretty good. We've got a confidence interval. Now write the statement that correctly interprets a confidence interval. So one has a 95% confidence interval that there's a 95% chance that the true value of the profit will be between these upper and lower right here. This is what this means. I had to read all these. No. Obviously, I wasn't reading close enough. 95. Okay. 121. Ugh. I hate how they play parsec. So I'm going to be honest, guys. I'm going to ask you for this. This, I would ask you to write it out. Probably all these are. This is one has a 95% confidence interval from the lower bound to the upper bound actually does contain the truth. That's the same thing. Okay. I'll have to sit and think about what the difference are. But anyways, the point is that you are 95% confident that your true proportion is between these values, which is what I thought C said. But obviously that's what I get for reading and doing this at the same time. But that's the idea here, is that, okay, I don't know what the actual population proportion is. But based on this sample, with the 95% certainty, it should be in these values. So it's probably not actually this point estimate, 0.437, but it's between these values. And you're going to find most of the time, as you're reading journals, they like to give you population estimates because they give you, okay, it's between these values. They're not going to give you a specific value. They're going to give you a range of values.